Okay, everyone, let's start this class. And yeah, today we will now talk about new things. Actually, as we have already finished the level 1, you will know like the level 1, it is not difficult, but it's very fundamental. Yeah, and let's review the level 1 and to strength what you have already learned, and to give your lab result, like make it more sense. Yeah. Okay, let's start. And firstly, let's just do a quick review last lab. What did we do in the last lab? Yeah. Yeah. And yeah. What? Intro what? Oh yeah, blackboarding, yeah. And what else? What else?
Turning on like buttons and coding, have power going through your wires, turn on LEDs and all of that.
Yeah, that's true. That's true. What else? What else? Hi, Alex. Okay. Yeah. What did we do in last lab? Yeah. Yeah. I think you don't forget it. Am I right? Okay. Yeah. Blink an LED and read a button input. Am I right? Yeah. What we use? Like what? Yeah. PQW. Oh. What else?
MicroPython.
Yeah. MicroPython. Yeah. Programming thing. Yeah, definitely. Yeah, usually, yeah, we use this one, those ones. Yeah, output, input, like some code, and like a while true time sleep. Yeah, and this is what we have already done for the last lab. And let's talk about what is a microcontroller. Yeah, based on the lab 1, what is a microcontroller?
It's a system.
Yeah, it is a system. Yeah, it is a system. Yeah, what else?
It receives input.
Yeah.
And it gives that out.
Yeah, that's true. Yeah, it has a microprocessor. Yeah. Yeah.
Like that allows the microprocessor to control the real world.
Yeah, that's true. I think, yeah. Actually, the first thing is a microcontroller is not a computer. Yeah, you know that, am I right? Yeah. Why? Why the microcontroller is not a computer? What a computer can do? Yeah, anything. Who says anything? Yeah, you're right. Anything like everything you can think about that. Yeah, but the microcontroller cannot. Yeah, actually, it is just a small system. You can see it is a tiny computer, but it has only like a CPU, memory, pins, and other like simple components. But it's not a computer. It only can deal with some simple tasks. Yeah, and interact with like some devices. And you can see, yeah, a microcontroller only can interact with the world through pins. That makes sense to you? Yeah, because you can see, based on the lab 1, if you want to do something, you need to connect the circuit to specific pin. Am I right? Yeah. About this one, do you have any questions? No? Okay. Yeah, this is a microcontroller. And we know, like for the microcontroller, the PQW is not the only microcontroller we can use. Yeah, you can use Pico. You know what's the difference between Pico and PQW? Yeah, one has Wi-Fi and one doesn't have Wi-Fi. Yeah, and also there are other like microcontrollers you can use. Arduino. I think some students maybe use this one before, like Arduino. Yeah, right. Arduino. Have you ever used this one before? Yeah, ESP32? No, yeah, maybe, and yeah, anyway, those are all microcontrollers. Do you know what's the difference?
I got it.
Actually, yeah, if you are maybe like the Arduino, do you know like what language does the Arduino use? Yeah, yeah. Like for different like microcontroller, maybe you use different programming language. And also some like one specific microcontroller maybe focus on different area. Yeah, some like microcontrollers maybe are suitable for like dealing with the interaction with the specific devices. Yeah, so those are the difference. But the fundamental theory behind those microcontrollers are same. Yeah, that makes sense to you? Okay. Okay, what can a microcontroller do? Yeah, based on the lab one, what can a microcontroller do? Yeah, this labs, do you know?
Output it, like,
Put what?
it can output an electric current.
Yeah, output like current voltage like that. I'm right? Yeah. You can see a microcontroller can only read the voltage on a pin or output voltage on pin. It can only do those two. It cannot do any other things. Yeah, actually, you can see we can blink an LED. We can like use sense button, but you need to know the microcontroller. It does not understand light, buttons, motors, other like sensors we will use in the following labs. Yeah, the microcontroller cannot do that. The microcontroller can only read the voltage on a pin or like output voltage on a pin. This is a microcontroller can only do. Yeah. Yeah, it only understand high and low. So, which means if you want to let the microcontroller do something for you, you need to give him like a reasonable voltage change. That makes sense to you? Yeah, if you can give him, for example, you want the like the microcontroller can wants the LED off, which means I just output the zero like voltage. Am I right? If the microcontroller can like make the like LED on, which means I need the microcontroller can should give the pin 3.3 like voltage output like that. That makes sense to you? Yeah, it cannot understand LED like light like buttons things. Yeah. Okay. This is what can a microcontroller do? And then let's talk about the PQW. Based on the lab one, like if you want to let the PQW work, the first step, what's the first step? Do you know what's the first step?
Or
Turn it on, Amra. Yeah, plug the keyboard and connect the PQW to the computer. Am I right? Yeah, but I don't know if you know that the PQW also can work independently. Yeah, because you can see when we do the labs, we usually connect the PQW with our computer and laptop. Yeah, but if you want the like PQW works independently, which means if you want to integrate this PQW into one device, which means you cannot connect the PQW with your computer laptop. What should you do? How can you give PQW a power? Do you know?
Computer?
Huh?
Computer?
Computer? What?
Plug it into-
Yeah, you can plug it, but sometimes if you want the PQW control a motor, like control that small car, and you need to like put the PQW integrated into that. For example, that one. Do you see that one? Small car. Yeah. If you want to make the PQW or like make that like a small car run, you need to integrate it into that small car. And how can you give it a power.
That's, terminal, and pin out, hardwire, yeah.
What? Can you speak again?
It has a power, like pin out, that you can hardwire to the end. Like positive, negative.
Yeah, I think you're right. Like you can see here, let's observe the PQW. You can see this PQW here. When you use the lab one, you just plug this PQW with using a cable to your laptop, and then here this is the output voltage, 3.3 around 3.3. You use this one, am right, to connect to the your power, and then ground to the ground, am right. So which means you connect this here with cable to your laptop, and then you active your PQW, and then there will be an output voltage, am I right? But sometimes you need to integrate your PQW to the separate devices. Yeah, so you cannot plug it into your laptop, which means you need to here there is a VSV system, which means you just give this pin a voltage, connect here to a what? If you want to give this pin a voltage, what should you do?
Put 5 volts.
Yeah, 5 volt. A what? A battery, am I right? Specific a battery, am I right? So you connect here with the battery and ground to the battery ground. That makes sense to you? And then you will give this power. That makes sense to you? Yeah, and this V bus is just also an output voltage, but this output voltage is around 5 volts. I don't know if you know that. You can try that. And then usually we will use 3.3 to control the pin, makes the pin works, makes some devices work. Yeah, and then this is what we have. We know about the PQW power thing. Yeah, you can give a PQW power using your laptop, connect using a cable to connect here. Also, you can use some battery. Am I right? And then let's see this PQW. You can see except here, and then you can see also except this 35, and here some are ground. What does ground mean? Do you know what's ground mean?
Like no voltage.
No voltage, yeah. Which means if you want to connect your device, your output, your sensor thing, like some other equipment, you need to put the ground together, am I right? So which means you need to connect Pico's ground and with your with your own devices, our devices ground together. And let's review the lab one we use here, am I right? We use this as our ground. Can we use this one? Pin 3, pin 8, pin 30, pin 20, 28. Can we use those ones? Yeah, we can use. Actually, those are all ground. They are same. Yeah, but why? There are so many ground? You know why? You know why there are so many ground? Guess.
So you can make more than just one separate circuit?
Yeah, that's true. Yeah, sometimes your circuit maybe are very complicated. Your circuit maybe is not as easy as lab one. It will connect different devices, am I right? So you can use just one ground, but it's not very convenient for you. Yeah, for example, this is your breadboard like this, and you connect here a device, here the other device, and you just connect this part with this one, this part with this one, am I right? Okay, and then let's observe. And you can see, except those power part and some ground, others are all green. Green is GP, general purpose, which means general purpose input output. Am I right? general output is just what we talk about in lab 1. It's just like a give like voltage input or voltage output. And you can see we use GP16 and GP15 in our lab 1, am I right? Can we use other things like GP0, GP1, GP like 2, 3? Can we use those ones? Can we use those ones? Can we use like a GP0, GP1, GP2, GP3 to replace GP15, GP16 in our lab 1?
Yes.
Yeah, we can use. Actually, they're the same thing. But did you notice that there are other things? SPI, like I2C, UART. Did you finish the homework 1? So what are those? Huh? Yeah, communication property, protocol. Yeah, proto. Yes, sorry, my pronunciation. Yeah. So what are that? What is that?
There's different ways that the Pico can communicate with different partial differences.
Yeah, that's right. Like a Pico W will communicate with other different devices, but other different devices will have different like data transfer like ways. Yeah. For example, I will give you a very easy example. You guys speak English. Yeah. For example, I cannot speak English. I just can speak Chinese. Yeah. So if we want to communicate with each other, we need to follow some rules. Am I right? Otherwise, we cannot understand each other. And for example, there is the other one. He cannot speak Chinese, English. He can only speak Spanish. So he needs the other rules to communicate with ours. Am I right? Yeah. So those like a different like a communication protocol, like which means how can other devices communicate with Pico W using different ways like that. Yeah, actually, we will talk about those things later. Yeah, but then you can see the Pico W is just like the power thing, different input, output, and then you can see the most important is this part. What's this? Like a
Not the central processing unit.
yes, like central processor. And we will talk about this in next class. And then our next class will relate it to this part. Yeah. Okay, this is a general information for the Pico W. Yeah, any questions so far? Okay, let's continue. Okay, let's talk about what is Pico, what is the GPIO pin? Actually, based on lab 1, you will know like the Pico, the GPIO pin is very important to us. Like in the lab 1 and including the following labs. Okay, what is a GPIO pin? Actually, the full name for the GPIO is general purpose input output. Yeah, and like what it can be configured as output like send voltage and the input read voltage. Yeah, we have already learned this in lab 1. I'm right. Yeah, this is we have already learned. And then for the voltage level, the high means like around 3.3, and the low with the voltage means around 0. Maybe it's not like specific 3.3 or specific 0, but it's around like have the tiny differences. Yeah, that makes sense to you. Okay, and the same thing can be input or output, depends on the configuration. Yeah, actually, you can see you can use pin 15 as input, or also you can use pin 15 as output. Yeah, like just depends on the configuration. How can you configure it? Do you remember? How can you configure the specific pin as output or input?
Oh, it's through the code.
Yeah. Do you remember that? When you want to like configure it as input or output, you just use the code to define the pin. Do you remember that? Yeah, just remember that. Okay. Let's review the LED example. Okay, for the LED example, actually the pin configured as output. Yeah, you know that, am I right? Yeah, and then the pin head, which means the LED on, the pin low, which means the LED off. Like a pin head, what does that mean? The basic thing, pin head, it will output what?
3.3.
Yeah, 3.3, and the pin low will output what? 0. Yeah. So yeah, actually, the LED is not smart, and the LED reacts only to the voltage. Am I right? So the MC MC is just the microcontroller unit. Yeah, it's just a short name for the microcontroller unit. It controls the brightness by controlling voltage over time. Yeah, so when we talk about the control thing, the peak microcontroller thing, we just control the voltage, like the current thing. Yeah, we don't control actually the specific the basic thing. We don't control LED. We don't control button. We don't control like if the following like levels. We don't control some sensors. Yeah, we just control the voltage. Yeah, this is a fundamental and basic thing. Any questions so far? Any questions? Okay. And then let's talk about the button example. Actually, the button example, we just like consider the detail is input. Yeah, configure as input. And then button connects pins to ground or like 3.3. And the microcontroller just reads the voltage and enter press high or low. Okay, sorry. And this is what we talk about in the YAR class. Actually, this is sorry. This is the original one, I'm right, without the blue line, I'm right? And you can see, if we didn't connect this pin, and for example, sorry, let me try to, hey, let me try to, okay. Okay, yeah, this is the original one, am I right? You just like, but for this one, you didn't connect it to a pin, am I right? And this is just the power. And this, if you connect if you click the button, and the 3.3 will goes from here and to here and to here to here to the ground, am I right? This is a circle, and then let the LED on, am I right? So if we want to like read the voltage, which means we need to connect the pin like before the resistor, am I right? Because before the resistor, and then if you connect the button, and we can read the voltage change. That makes sense to you? Like this. That makes sense to you? Any questions so far? And I don't know if you notice, if you connect your circuit like this, sometimes some weird results will come out. I don't know if you notice that. Do you know why? Yeah, if you connect, we know like if we didn't connect this like a button, the circuit is like this, and if we because we want to like connect the voltage, so we just put the pin here, connect to here, because when you connect the button and then you just read the voltage, am I right? When you didn't click the button, you cannot read the voltage. But if you connect your circuit like this, you will find sometimes you find your results are right, but sometimes your results are very weird. Do you know why? I don't know if you notice that. What? Yeah, I think so. I think you are right. Yeah, because there is LED. Actually, the LED, I don't know if you have already learned the electronics. The LED works non-linear. It is a non-linear system. It's not just like when the when you give LED a power, it will on. When you cut off, it will off. Because sometimes the voltage will sieve in LED. The LED is a non-linear system. So this button will like these pins will affect by this LED very easily. So if let you to improve this circuit. How can you do that? Huh?
Insert pull up or pull down resistor.
You mean like remove the resistor and the capacitor and the LED?
Insert.
Oh, you mean pull down the actually it's the other question. Yeah, your question is the floating problem, floating point problem. But this one is just like if I connect the circuit like this, sometimes my result will be affected by this LED because the LED works nonlinear. So sometimes even I didn't connect the button, and I can detect the voltage. That makes sense to you? So how can I improve this circuit? Yeah, like remove the LED, right? That makes sense to you? Yeah, so actually you can make your circuit like this. Just connect the button with the power directly, and then goes to the pin. If you click the button, which means that there will be a 3.3. If you didn't, which means you disconnect with the 3.3. That makes sense to you? Yeah, just remember that if you want to control these things, use button to control input pin, you just try to remove the LED. The LED is the thing makes your circuit very weird. Okay, any questions so far? Any questions? Okay, let me ask you a question. Like, I know some students maybe want to, sometimes I don't know like if my button works or not. So I want to add an LED, like a LED to show I click my button. And when I click my button, the LED is on. When I did not click the button, the LED will off. And for this circuit, how can you do that? If you want to add an LED, like when I click a button, my LED will, yeah, how can you do that?
You could change the resistor to be like on the same column and then add an LED to like the left and then it'll wire an output.
You mean for this circuit you change,
Yeah.
you just put,
I would change that resistor, right? Would you change the resistor at
you
all?
change this resistor
Say
I would add the LED to the top right,
here,
no, on
here?
the right side, or my right,
Oh, you're right, this one,
put it on that, yeah,
this one,
yeah.
and to connect where?
Positive to the button, negative to ground.
Positive to the button, negative to the ground. But did you notice if you just put it just like that, it's just same with this one. It's just like no the other resistor, but the basic thing is same with this one. That makes sense? Yeah, this is what I want to tell you. Just remember, if you use a microcontroller, just try to use one pin to control a specific thing. And then if you want to use button to control a LED, you can use the other pin. For example, pin here you use pin 15, am I right? Then you use pin 16 to connect pin 16 with the LED and then go to the ground. And I have already given you a hint. What's the next step? Yeah, for now I just give you the other pin, am I right? Pin 16, am I right? And connect pin 16 with the LED and to the ground. And what can you do to let this button to control this LED? What can you do? Try to guess. Guess. Do you remember like when we use the code to like if we just the button value is 1, and then we do something. If the button value is 0, we will now do something, am I right? It's the same thing. If we press a button, what we will do? We will let the pin 16 output a voltage. Otherwise, we will not let the pin output a voltage. Does this make sense to you? Which means we just use our code to make this button to control the LED. And any questions so far? Okay, am I clear? Okay, that's great. Actually, we will talk about why like for the microcontroller, the pin one pin can only control one thing. Yeah, we will talk about in next class. Okay, let's talk about the floating pin problem. This is like the Alex just talked about. What is a floating pin? You don't know, am I right? You never heard this before, am I right? Actually, you can see if we use this circuit to let the button to control this pin input, am I right? Yeah, but you can see if we didn't click this button and this pin actually don't have the default voltage, don't have a default value, it will have some problem. Yeah, if a button is not pressed, pin may not be connected to anything. You can see, am I right? Yeah, so voltage becomes unstable. And MCU, just this people, like also microcontroller unit, reads random values. Yeah, this problem we called floating pin problem. Yeah, any questions so far? Okay, and this pin, like floating pin problem, will result like button seems to active randomly. Yeah, you can see if you didn't give this pin like a default value, yeah, this pin will read some like random value. Am I right? Okay, any questions so far? Then how can we resolve this problem? How can we resolve this problem? Actually, you have already done this in lab 1. How? How to resolve this problem? You have already done this in lab 1, actually.
I think it's
Huh?
sleep it after you press it.
Yeah. Actually, Alex have already, pull down, pull up, pull down. Yeah, you can see we can use pull down or pull up to resolve this problem. Why? Because we give the pin a default value. Does make sense to you? Yeah, like pull down, which means we give the pin a default value. When button is not pressed, the pin is low. When button is pressed, the pin is high. Yeah, pull down prevents floating input. Yeah, this is like a code we use in our lab 1. That makes sense to you? Yeah, we also can use the pull up, but the pull up is just the opposite value. Like also give the pin a default value, but when button is not pressed, the pin will high, which means the default value is high. When button is pressed, the pin will be low. And the pull up just also prevents floating input. Then let's talk about the circuit for pin pull down and pull up. Yeah, you can see the pull up. What does that mean? Which means you just connect this pin to the VCC directly. If you didn't connect here, which means you just this pin just connect to the VC 3.3 like always. It will give this pin like a default value like 1. That makes sense to you? This is we call it pull up, and then this is just a pull down, which means we just connect this pin with ground like directly. If we didn't connect click the button, which means we always like the pin is always like 0. That makes sense to you? Yeah, this is just a circuit for the pin pull up, pull down. Any questions so far? Any question? Okay, let me ask you a question. Which one do you think is like a most common circuit we will use in the real application? Which one? Pull up or pull down? Yeah? Put down? Are you sure?
Pull up, because most of those are, posted.
Yeah, I think you're right. Actually, the pull-ups are often preferred in the common, like in the real world application. Why? You can see the pull-up, which means it will change the circuit from a high to low. That makes sense to you. When you like press when you connect this circuit, it will just go this two, which means from the high to low. Am I right? Yeah, the ground is more stable than VCC, which means when you press it, it will go through a ground, which change from the high to low. Yeah, and do you know like the change is always gives the circuit like a like an unpredicted result sometimes. So yeah, the ground is more stable than VCC. The ground is a solid reference. VCC can have some noise and ripple, which means if you connect a button and connect it to the change from the VCC to ground, your circuit is more stable, will be more stable. And then like the better noise immunity, like low is harder to disturb than high. Pull-up designs actively pull the signal to ground when pressed, and a safer default behavior. Yeah, because it will active no. Disconnect or broken wires often read high instead of floating. Like hardware and industry conversion, like many like MCUs provide reliable internal pull-ups. The common faces reset like interrupts I2C use pull-ups. Yeah, you can see the pull-ups. It can make your working circuit more reliable, more stable. Does this make sense to you? Yeah, any questions so far? Okay. And how does the program run? Yeah, for the level 1, we run some code, am I right? But do you know how does the program run? Yeah, actually for the Python, like for the C++, I know it usually now runs from top to bottom, but for the Python, the code runs from top to bottom. You can see from this is the code we use. It always run from the like top to the bottom. You can try if you like remove you can change the machine here to some like randomly word, and when you run the code, it will give you an error. You cannot run the next code, which means it will like run from the top to the bottom. If your sentence 1 has something wrong, it will stop. If your sentence 2 has something wrong, it will stop here. If your sentence 3 stops, and it will give you a hint there are something wrong. I know like some students met some problem, like code problems when you have the level 1. You I don't know if you read the error like the sorting give you. Sometimes, not sometimes, always he will give you which line you have some problem. Yeah, did you notice that? And then you just find that line and try to find the errors in that line, all the previous line. Yeah, it will now like it will impossible to check the following line, because which means when you run this line, if this line is something wrong, it will stop here. Does it make sense to you? Yeah. Okay, the MCU is always running, and there is no pause unless you add one. Actually, you can see here. From the where true, what does that mean?
Always.
Yeah, it always true, which means this loop will always run. Am I right? And what does that mean? If you like didn't stop this code or like manually, will this code print this one finished? Will this code print finish? No, yeah. Like you will notice that if you run this code and if you didn't click the stop in the software, like this code will run continuously. Yeah, that makes sense to you? Okay. Any questions so far? Okay, while true means yeah, run forever. Check button, update LED, repeat. Okay, and okay, what does time sleep do? Yeah, I think just Eric mentioned this just now. What does time sleep do?
Cuts off voltage for a certain amount of time.
Huh?
Does it cut off voltage for a certain amount of time?
Collect voltage.
It stops, like,
Oh, stop. Yeah, stops. Yeah, actually, the sleep is just pause the CPU, which means if you run the sleep, the CPU will stop running. It will it will run the code during this time, and during sleep, no button checking, and no LED updates. Yeah, and no other tasks. When you use time sleep, other tasks which means if you click button, if you change your circuit, blah blah blah, nothing will change. That makes sense to you? Yeah, this is time sleep do, and the pause is simple and easy to understand. Am I right? Yeah, you can see when I sleep, which means when you sleep, you cannot do anything. Am I right? Including eating, blah 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 blah, and it's easy to understand. But the cause blocks everything. Am I right? Yeah, like 4-hour lab one, the circuit is very easy, am I right? But for some complicated circuit, you want maybe this part, this logic, this circuit with some result, it will stop, am I right? But you hope the other circuit will run to get the other thing to send. Maybe there is the other sensor. You want to use the other circuit to get the other sensor's data. You don't want the CPU stops, am I right? So we will talk about we also will talk about it in next class. Yeah, we will know how can we using some strategy to let the CPU works for one part, like when the other part stops. Yeah, we will talk about in the next class. Okay. Yeah, why does blocking matter? Yeah, the first thing, the LED blinking works. Am I right? Yeah, which means when you sleep, the LED will not blink. It will it will off. Am I right? And when the sleep when past the sleep, and it will on like that. And the button response becomes slow. Yeah, it will stop if you click the button always. It will slow the button, and then your connect data will be more accurate. Yeah, and this is okay for learning, but not good for complex systems. Like I said before, just now. Yeah, we will talk about in next class how can we improve this part. Okay. Sorry. When we do the level one, there are some mistakes some students will make, like wrong GPIO pin number. Yeah, when you have this code, you will see if you use GP15 but you write GP16, and it will not work. Yeah, so try to check the GPIO pin and pin set as an output instead of input. Yeah, when you want this pin work as an output, try set it as an output, not input. Yeah, it's different. It's totally different. Yeah, opposite. And missing pull down and pull up setting. If you miss this one, and there will be no default value, and there will be floating pin problem, and your connection data will randomly. Yeah, actually, we will we will also do some lab about this in next part. And too much time sleeping. You can if you just set the time too long, or you will find out there is no result for you. So yeah, and most problems are hardware understanding issues, not Python errors. Actually, for the microcontroller, the code part is not difficult. Actually, it's quite easy. The logic is easy, but mostly it's just a hardware understanding. Yeah, because the microcontroller is just try to connect the hardware and the software together, and the software just try to make the hardware works. So yeah, so you need to pay attention to this part. Yeah, and then what comes next? Yeah, what are we know? What are we now? Like we now understand GPIO. We now understand the button input. We now understand the program flow. The next step will focus on better timing, which means that we can make different tasks works together. Yeah, at the same time like that, and doing multiple tasks and more efficient control. Yeah, like you can see when we control the LED and we try to like adjust the time sleep to make the LED blinking in a specific frequency. Am I right? The period but we can do it in the other efficient way. Yeah, and we will talk about it in the next class. Yeah, and do it in the next lab. Okay. This is just like some summary for what we have already learned. Microcontrollers works with voltage. Just remember that, like it only reads voltage and all connect the voltage. The GPL pins can be input or output. The buttons require pull up or pull down. Sleep is a simple but blocking. Understanding and why I use this class to talk about more about the pins, because the blinking and button is the fundamental of everything else. You can see if you understand this more and you know like how the microcontroller works, and you can you will understand the microcontroller deeply, and you can finish the other labs well. Yeah, like better. Yeah, any questions so far? Okay, yeah, this is today's class, and for the next lab, I hope. I don't know if you hope. I hope next Monday we'll have class. Yeah, I don't know because it's very cold and yeah. And next Monday we will have the lab theory in the morning, and we will talk about how to use Pico and code to do the multiple tasks at the same time, and also we will try to control LED using the efficient way. Yeah. This is what we will do in next lab. Okay, any questions so far? Okay, that's great.